We are live, Dima. Hello, hello, and welcome to the second episode of AI a la carte. We are keeping with the French team. We had a small discussion in our marketing team last time, and we decided to rename our show from Cooking AI into AI a la carte. This is how it's going to be called going forward. And welcome everybody who is joining us for the first time. Welcome everybody who is joining us for the second time. We're going to have a lot of fun today because today we are launching a very exciting new functionality. I personally have been waiting for this functionality for a long time. Our development team has finally delivered. There may be some hiccups. It's literally we just pushed it to production today, but we will talk about this new functionality that is called Mapping Node quite a lot today. But it will allow you to do amazing things with your agents. But before we go there, let us just see what we're gonna talk about today. This is the brief agenda for today. We will try to follow it, but sometimes we can get carried away. And Andre, my guest from the last time, will join us soon as well. But before he does, let's just really quickly go through this agenda. So we will do a quick recap of the first episode, what we learned there, and what skills you have acquired doing that. Then we will look at the really quick bonus agent, which will allow you to summarize YouTube videos for your further publishing to your blog or for your understanding. I know this is a task that people have pretty often, and there is a very simple agent that can help you do that. Then we'll talk about RAG. If you are following the AI, you know that RAG or retrieval augmented generation is a very hot topic, and everybody is talking about RAG. So we will discuss what it is, how easy it is to implement with Integral, and then we will finally move towards this new functionality that will allow us to work with lists of all kinds of information, that will allow us to build what I call your own personal research assistant. So hopefully with this agent, maybe we won't build it completely, but you will be able to get lots of help when researching any topic. Just to give you an example, for a long, long time, I've wanted an agent that would read the internet for me. Of course, not all of the internet because that's too much information, but some of the key sources of information that are relevant to me, such as new AI papers, news about technology, something that interests me, such as, I don't know, news about physics, etc. I don't have time to do it myself, and I'm sure many of you follow the same pattern. You browse the web, you open some link, you keep it in the folder or in the bookmark, and then you never come back to it, even though it's interesting for you. So we will create an agent that takes this headache of reading all the information out. It will read all of it for us. It will summarize it for us. It will put it to its memory, and then we'll be able to have conversations with this agent about this new information. I am personally very excited about it. We haven't built this agent yet. This is a live show, as we discussed last time. So please follow, please ask questions, and let's get to it. So with that, let's also welcome Andrei to our show. Andrei, and I will move my camera a little bit since.
Hello, everybody. Again, I'm just a viewer here. I'm just someone who is going to have a conversation with Anton, pretend that I'm interested in the new functionality and I want to know more, but I don't really have the background to fully appreciate the awesome things that we can now do with the new features.
Okay, so YouTube summarization agent. Before we get there, let's quickly recap what we did last time. Last time, if you recall, we created an agent to which you put a screenshot of the menu, and then it talks to you and it tells really exciting stories about this menu and the dishes that are available on this menu. We learned how to do basic system prompting. We learned how to create text-to-speech generation. We learned how to generate pictures, and we learned how to search the web in a very basic way.
So that was all in the context of the menu research agent that we were building. Is that right?
Yes.
The new one, what we have on the screen here is the YouTube summarization. That's what we're going to do today.
No. YouTube summarization is just a bonus agent that will take us literally 2 minutes, because very often people around me ask, okay, we need to do a summary of this, of that, or we need to do this audio interview and make a text based on it. So we will show how to do it today, really quick, because it's fun and it's quick. So let's take a look at the last video that we had. I have to switch our screens here. So this is the YouTube video of what we have streamed last time. And you can do it with pretty much any video. So what we're gonna do, we're gonna browse here. Here you'll have to press more to see the transcript. And it's actually also one other advanced topic, because at Integral, you're able to integrate via API with pretty much any system, including YouTube. But since we haven't learned that yet, we will do it manually so that you see how easy it is to do in the manual process, and then we will provide the more complicated agent with integrations. So here you just have to say show transcript. You will see the transcript here on the right. Then all you need to do, just select all of this transcript, because, for instance, you found an interesting video, but it's too long and you don't want to listen to all of it, or you want just the gist of it. So we copy this transcript, then we go back to our Integral Studio. Let's go to the agent that I have created. It's called YouTube Summarizer. I actually tried it once already, but I will show how to do it. So here we just copy the whole transcript without any edits, without anything. And we press enter, and let's see what happens. And this agent will summarize for us very nicely what this video is about. As you can see, it not just summarizes, but it creates, nice headers, subheaders. It actually talks about what kind of system prompts we wrote in that video. So this is a very good accompaniment to the video that we did on how to build agents. But again, you can use this agent for any video. And this is a very, very easy agent. There is nothing inside. It's just one LLM with a pretty basic system prompt, which tells it to do just that, to summarize it, to fix grammatical errors, and to add some nice formatting. So it's just 3 sentences. And
so that's the essence of the agent. What you had there in the prompt is everything that was necessary.
Exactly, everything.
To
Yeah,
produce this
nothing more
markup.
complicated. Yeah. So if you want to improve it, we will be able to add YouTube integration eventually, so that you just enter the link to the YouTube video and it does the same. But now it's a very simple copy paste, and you get this nice summary. And here we're actually using Gemini 1.5 model for the simple reason that it has the biggest context of what it can take. So if you have a really long video, it's not a problem for Gemini. You can just shove everything into it and it will give you the summary. So let's let's take a look once again at what a nice summary it creates. So there is headers, subheaders. We talk about what AI agents are. We talk about building this French agent step by step. So again, in 2 seconds, you get a very nice summary of any video that you like.
It's pretty nice. I think I've seen something very, very similar as a service. And here we've done it in just a couple of lines.
Exactly. And of course, if, for instance, you want to do an interview that you did, like an audio interview that you recorded with somebody, we have a node that allows you to convert this audio into text first, and then you put it to the same agent and you will get a nice summary. So, and as Andrei mentions, yes, there are services that charge you like $5 per run for stuff like that. You can do it with Integral much easier, much cheaper, much faster. So let's see what else do we have on the menu today. RAG, as I mentioned in the beginning, a very interesting topic, retrieval augmented generation. Why is it important? Just one more slide with content I'm going to show today, and then we'll move to demos and discussions. So, as you know, and as we have discussed last time, and if you are following the whole hype around LLMs or large language models, you know that they what is called hallucinate. Hallucination means that if you ask them something that they haven't really learned, which means they haven't seen the answer to this question many times during training stage, they will still provide an answer to you, but it will probably be deceiving. It will probably be wrong. And the way around it, the way to make LLMs provide correct answers, nice answers, is to put relevant information into context, just like we show on the slide right now. Basically, anything, when you talk to ChatGPT, your chat history, it just gets put in the context. If you wanted to give you some nice answers about some research paper, you have to convert it into text and again, put it into the context. So the more relevant, the better information is in the context, the better results there are. And this is the essence of RAG. Basically, the way it works is that you ask a question of an LLM. We do a search to find relevant, nice, correct information based on which the LLM should give you the answer. We put this information into the context, and then we let the LLM do its magic. This way, it will be accurate, and you still get all the fun features of LLM of being able to imitate the human language, etc., etc. So RAG is absolutely important. You cannot build any useful agent without RAG.
So how Anton, let me interrupt you for a second and see if I understand this correctly. And I've dealt with it in the past a little bit, so I have some idea of how it can be useful. So when you talk to people about using AI for their specific practical needs, the issue very often comes up that there's nothing in the internet, in the public domain, that was used to train the models that has to do with our business. And maybe we need to train our own model because we have our own information, our own data, and we need the model to be more precise and hallucinate less on the topics and issues that we're dealing with. But what people actually mean is that they want to provide a little more context, a little more information to the LLMs that are already out there, that are working pretty well. They just needed to know a little more about what you need. And by providing local context, by providing this, like, for example, if you want to answer emails, prepare drafts for answering emails, you can put some old answers that you have written in the context in this RAG, and they will be used to prepare new emails. It almost feels like you're training the system, but you're not. You're just providing a little more text to use when it's working on your
exactly
project.
Exactly. And actually, it is called training. It's called few shot learning. You give several examples to an LLM, write in the prompt, and it learns from these examples on the fly. It does not remember them for the future use, but it learns them on the fly. So basically, it is also a kind of learning. But the main thing is that it's important to always use it, and that it is very easy to use with Integral. And let's take a quick look how we do that before we move to building this our own research assistant, which is a really amazing thing. So first, let me switch back to sharing my screen. I can go here. Let's take the simplest possible agent that we can build, which is just input, LLM, and output. And let's take our reasonable default, which we always use, which is GPT-4o. Let's save it as a silly agent. And let's test why RAG is important. We go to silly agent and we ask it, who is Anton Antic, which is me. I am not a very public person, so as you can see, the response is, I have no idea who Anton Antic is. And this is basically even a good scenario, because if you use a different LLM or if you phrase the question a little bit differently, it will hallucinate. It will come up with a story like Anton Antic is an ancient Serbian guitar player or something like that. You definitely don't want that. You want your LLMs, your agents, to provide the correct answers to do that. So there are two ways to remedy this. The first one we actually looked at last time. It's the easiest way to do RAG is just to do Google search. And let's quickly take a look to make sure that it works. So we go back to designing this agent. We'll just add really quick the Google search box and one readability box, because it will need to read what we have found. So really quickly, user prompt, attach to search query, limit the results to 2. Then we attach readability boxes. If you recall, readability boxes, they read our URLs and provide the content of what is inside those URLs, so you always need them. And by the way, in the mapping node will make what we are doing right now much easier, but we'll get to it in the second part of our show. So here we will have context that Google has found for us based on our query. So now what we need to do, we just put it in the context like we showed in the picture. We put it in the context as system prompt, and this is RAG. That's it. We built a RAG-enabled agent in 30 seconds. We just need to provide a bit more instruction here, and we will say in system prompt something like, please use the following additional context when responding to the user, but only if it's relevant. And here we have these two pieces of context that we have found and read. So now let's save it. And let's test it again. Go back to chat and we ask exactly the same question. Who is Anton Antic? So now what is happening is, first we go to Google, we search for whatever the user has entered, then we read the contents of these websites, we put them into the context of our LLM, and then it will provide an answer based on this context, hopefully. Let's see. Yeah, it takes some time because sometimes the readability box has to retry to be able to read some websites that prohibit working with bots. So as you can see, it has found some information about me. I'm not sure what this is. It might be LinkedIn, but now it gives you an accurate information because we put a relevant piece of info into the context. This is RAG in essence. So you can do RAG with Google search. But there is a much better way to do RAG via so-called vector memory. So let's take a look at it, what it is. I will just go back to our slide and show you one more slide. Really quick, another 30 seconds of theory of what is vector memory and what is vector search. So it turns out, and this was actually the research that has enabled this whole LLM, ChatGPT, etc. revolution, is that we can represent the words or paragraphs of text, or doesn't matter, any text, we can represent as mathematical vectors, multidimensional vectors. It's basically a bunch of numbers, lots of numbers, 1,500 numbers or 3,000 numbers. There are different approaches to do that. So it's a very, very long vector. From math at school, you're familiar with what a two-dimensional vector is. It's basically just a dot on the plane. Here it's a dot in a multi-dimensional space. But all the same mathematical rules apply. So what it turns out is that the meaning of the words and of the concepts gets preserved in this mathematical representation. And this is really the amazing thing that drives LLMs, that drives everything that's happening here. And this equation here shows exactly that. If you create vectors for queen, for king, for man, for woman, this equation will hold, which means you can manipulate the meaning in a mathematical way. And this also means that you can search by meaning. So you can take any piece of text, convert it into a vector, do this vector search, and then you will be able to find much more relevant pieces of information because they search by meaning. Google searches by keywords. This is search by meaning. So vector memory is a much more efficient, much faster, and very good way to do RAG. So how do we do that? Andrei, are you following?
Yeah,
so far?
I'm a little puzzled how these mathematical operations and this linearity properties really help us with search. What's the connection there? What does it mean that we search by meaning? That maybe that there is some distance, like and the distance is literally the meaning.
Yeah,
is that what you're saying?
Distance is basically, well, it's an angle technically, but yeah, distance or an angle between.
Okay. So when we say that Google or AI will find something that is close to what we're looking for, it will be close in meaning, not in the way it's described.
Yes, and we will demonstrate it shortly. So actually, we have some questions here, and since we want to make this show interactive, there is the last one. What if query is more complex enough not to be loved by Google search? Exactly. That's a great question, and that happens many times, and we have actually addressed it last time. So I will not build an agent how to address it, but I will point out the way on what we need to do in such a case. So let me go back to sharing my screen. So what our viewer is asking is that if we put, I don't know, a lot of text here in user prompt, and it goes to search query, we won't find anything good because Google has to have very well formulated search queries. So the way to do it with our agents, and we did it last time, if you view the show, we basically add another LLM node, and we ask it to reformulate. So we connect it to user prompt, we delete this, and then we go with output in the search query. And then here in the system prompt, we will ask it to reformulate whatever user has written into a nice and concise Google search query. And this is a very good way to work around this problem. And it also showcases the power of agents, because with one LLM, you cannot do all this. Here, we are free to combine as many boxes as we want. This is a very often happening use case. You do want to reformulate whatever the user enters for nice and concise search queries, especially for Google. So this is something you would do, but we're not going to do it here. Okay, so let's go back to vector memory. As I mentioned, actually, at Integral, it is very easy to use. You go to the memory management tab, and then you can create new memory set. I cannot create it anymore because I already have created one and it's limited to my account, but it's already here. So I just choose it. And then you can add new memory items to this memory. And here you can either paste some text here and it will become part of your memory, or you can upload a file. So you can choose a file, you can upload it. Currently, we support PDFs and doc files and text files and HTML files, but we're constantly expanding the documents that you're able to upload. But basically, this way, you're able to build up your memory really fast. So let's show how it works with the same question about myself. So really quick, let's just copy what it has found about me to be lazy. So we copy this piece of information. We go back to our memory. We go to add memory item. We just copy this text here and we submit.
Okay, Anton, I have a practical question here.
Yeah.
So okay, now we find out that we can have our user-specific context, so some memory that we can build. Does it make sense to have like a single archive for all the projects, for all the apps that we're doing, or do we make it app-specific? Like, do we make it?
That's a great question. And the answer is it's better to experiment. On one hand, vector memory is very good if you have different items of different meaning. It actually filters them pretty good. But if you want to be extra sure, nobody forbids you to have dedicated vector memories for different use cases. And this way it will be even more efficient. But maybe you will lose out on some additional context.
If I use Integral very intensively, if I have a lot of AI projects, and my concern is the cost. If the more memory I have, the more potential there is that not very relevant stuff gets fed into the prompt, and I get charged for it. Is that a trivial thing, or is this something that will build up?
Well, no. Again, what you can do, you can have more memory sets. You can create as many as you want, and then they will be dedicated. And you can choose which set you use with your agents. So it shouldn't really be that much of an issue. So we give you the flexibility on how you want to manage this.
Okay, so the answer is to experiment.
Yeah. So as you can see here, you can also test the search with vector memory. Now we have only one item, so it obviously finds this one item, but we will put more items there with time. Why it's important to experiment? Because you see the score here. And the score is usually a threshold that you want to put when you do vector RAG in an agent. But let me demonstrate it real quick in an agent as well. So let's go back to the same agent that we were building. Let's just get rid of Google search. And now we do the same, but with vector search. So what we have here, we have a node that's called vector search. Once again, we do the same. We put user input into input. We will limit. Here, you can do pretty much any limit. Again, for the purpose of quick demonstration, since we only have one item, I'll just keep it to 1. And here we have minimum relevance score. 0.7 is usually a fair threshold, but again, depending on how many items you have in your library, feel free to experiment and find the threshold that you want.
So with this threshold, if I have 100,000 items that meet the threshold, will they all be fed to the prompt?
No, because you limit them additionally here. You obviously don't want to overload the context.
Okay, so 1 is the limit, and it can be 0 if it doesn't find anything relevant, right?
Exactly. If it doesn't find anything relevant, it won't put it here.
Okay.
So, and then in the output, embedded description is what we want, and we just connect it to system prompt, the same as we did with readability boxes with Google search. Only here we don't need the readability because vector search returns the piece of text right away. And we have the system prompt is already here. So we just save this agent. We go back and we will ask again, who is Anton Antic? And let's see that it's working. So as you can see now, it's much faster because vector search in general is much faster. So it finds the same piece of information and it responds. So just to demonstrate how to create a RAG using vector search. But basically, this is very, very simple. But this is the foundation that will allow you to solve many, many problems. So you can populate now your vector memory with your documents, like with your corporate documents, or with your personal documents, or with whatever interesting articles that you have read. You just put all of them into vector memory, and then you have an agent similar to this. And then you will be able to make sure, so here you will have to have not just one result, but maybe like 10 results, or I don't know, however many you want. And then whatever interesting pieces of information it will find based on your request, it will use them in communicating with you. And this
Okay.
is the foundation of also of our great and exciting research assistant agent, to which we will move shortly. Yes, Andrei, sorry.
So here's a question for you. So last week when we built our agent, we used chat history. And when ChatGPT came up with chat history, it was like a massive improvement in the quality of the results. So does it use the chat history the same way we're using Reg? Is it exactly the same thing that?
Yes, this is exactly what I was showing to you guys here. So chat history is kind of shown on this slide on the left, message 1, message 2, etc. So everything just gets connected and shoved into the context, and that's exactly how ChatGPT works. The only thing is ChatGPT has only chat history in its context. We are free here to put whatever we want into the context. This gives us full control, and this way we can build the agents that are much more useful.
Okay, so unless you copy or unless you use the chat history as an archive for all your local context, you cannot really do anything of that sort.
Right. And then
ChatGPT.
as your chat history grows, the quality of your conversation deteriorates, because the bigger the context, the more difficult it is for the LLM to
And
find.
there are no tools for fine-tuning it and sort of specifying relevance or the number of.
That's what we try to provide. Yeah. Okay. So yeah, and now the last and the most interesting section of today's show, and probably the most the longest, because again, I myself only played a little bit with these new nodes, but this is something I'm extremely excited about. I would say that now you can build extremely useful agents on Integrail. The only other missing piece, I would say, which you can implement manually right now via API, is running your agents on schedule, but we will add it. And then it will be complete. You can build agents of any complexity. So running your agents on schedule is not there yet, coming up soon. Mapping node was another thing that we were really hoping for and really excited about. So let me show. Yeah, sorry.
Yeah. So when you say that, okay, there is one missing piece, that it sounds like you have a specific application in your mind, like a specific task that you want to assign to your agents. What is it?
Yeah, it's exactly something that I started to describe in the beginning. I want to have an agent that every morning reads all of the internet, well, not all of it, but the relevant internet for me, finds the pieces of information that are relevant for me personally.
Okay.
And it will be a completely different set of information than for Andrei or for you, and you can fully customize it, obviously. But I want this agent to do it every morning. And then as I'm having morning coffee, it will tell me, look, here is this and that news on AI. Here is this and this news on Elon Musk flying us all to Mars, etc., etc. And then I just have a follow-up conversation with this agent.
So essentially, it monitors the media space given the specific kind of interest and instruction that we assign.
Right.
Okay.
Right. And so let us get to it. Let me show you why it is a difficult problem and how it is easy to solve with Integrail. So I will start sharing now something else. Okay, so let's go to CNN.com, and I will share this tab just as an example. So the front page of CNN has, and we checked it already with our agents previously. So if I want to get just the article links here, it will be around 100 links. So if I go and try to get all of the article links, it will be 100 links. But how can you do that? Manually takes a lot of time, impossible. You have to read all of it, you have to find it, you have to click, boring, terrible, nobody wants to do that. What people were doing previously, and it's a typical task called web scraping, right? You need to get some information from the web. You would write some code that understands what's in this page and will try to find the links that are relevant for you. But let's take a look what it entails, right? So let's do in view source. So here is the source of this page. As you can see, first, it's huge. Second, there is a crazy amount of junk. So if you try to write a parser that understands CNN.com, well, then you will have to write a separate parser for New York Times, for archive.org, for any other website, because all of them use different structure. So you have to write parsers for every source. Impossible task. Then, even if you write a parser for CNN.com, they change something on their website. You are in trouble again, because you will have to go back and adjust what they changed and how to work with all these divs and tags, etc., etc. Terrible, terrible, impossible. LLMs make it all just so much nicer. And let me show you how. So let's share this tab again. What do I have here? Yeah, let's try here. I'll just duplicate this a little bit homework, and I'll explain what I'm doing in a second. Okay, so what this does, so you have a readability box here, and by now you know that readability box reads the context of a certain website or a certain document. We feed CNN.com to this readability box. So basically it reads everything that I just shown to you. It converts it to much nicer markdown format so that there is less junk and it's easier for LLM to understand. But then we can have an LLM and we can ask it to give us a structured list of the links we are looking for. And this is amazing, guys. We are not telling how the specific link looks like, what tags are there, etc., etc. It just literally understands from the context. So let me just make it a little bit not like this, because this is going to be interesting. And as I mentioned, there will be like 90 links, so it's going to take too much time. So what I'm going to do, I'm going to put an additional instruction saying return maximum of 3 article objects. And then we save and we see what happens. So what I'm asking here, I'm asking this LLM to return a nicely formatted JSON, so an array of objects that a typical software would understand. And let's see if it works. So let's run it. So first, the readability is reading the whole CNN website. It pushes it to our LLM, and this produces output. So since we asked for just 3, you can see here is the results that we got, or we can see them on a nicely formatted JSON format. So it gives us very nicely formatted objects for every article: title, world's most polluted city, and URL, edition CNN.com, etc. So this is something that then we can use for future processing. But as I mentioned, if I don't limit it to 3, there will be 100 articles. I don't want 100 articles. I just want the information that is relevant to me. So how can I do that? Let's take the same agent. It's just I pre-built it to save time here live. It's, as you can see, the same 4 boxes. We have the CNN.com, we have readability, and we have an LLM with the same instructions, but I have added some additional instructions. I'm saying I don't want you to put the information that I don't want to see. So basically, I'm just saying I want to see news about Ukraine, and I want to see news about technology, especially AI. That's it. I'm not explaining, what filters have to be put. I'm not writing crazy regex expressions that developers should be familiar with. Nothing of that. It's just natural language. I just give instructions to it as I would to a human being. And then now I'm not limiting them to just 3 links, because I want to get all the links that are relevant to me. So let's see if this works and gives me a nicer list. So let's run it again. So readability is reading the website. Now the LLM tries to understand what I want from it, and it will give me the list of links. So it has worked for a bit longer, for 8 seconds now. And now I can see that I got 7 items. 7 items that are absolutely relevant to what I asked it for. Without clicking each link, without me trying to browse the website
Okay,
and understand
Anton,
it. Yeah.
let's be a little more realistic. So we don't really go and kind of sort through all the junk that the websites are giving us. So we can have tags on the websites. We can have sort of specific interests, and I think their idea is that they want to do the same thing for us too. Like they want to show us the information that is relevant to us, that is useful. So what I see on top of that we're getting out of this agent is that we're in full control, because they also wanted to show us advertisements. They want to show us something that might be distorted or
Yeah,
partially relevant.
Andrei, let me interrupt you here because they don't want to show us what we want to see. They want to show us something which makes them money. That's it.
But isn't it
Yeah,
the same thing though?
no. Here, but as you say, here I'm in full control. I'm seeing only what I want to see. It may be some obscure article that is somewhere way down below, right? But
So with
yeah,
that, I wasn't quite sure. So you, like, as a first step, you specified that we're looking at CNN. It will be much more useful and valuable to me if you could just say, okay, so any media source, look for the
you can do any media source, Andrei. We are building it up gradually. You can't, you
okay,
have to
all
crawl
right,
before you run. If you do that from the beginning, it's something. I mean, guys, what we're building right now, there are startups with $100 million funding that do just this one thing. What we are building right now. So this is something that is really
So
huge.
this is the first step, and then
This
we
is the
will
first step. It's just, yeah,
generalize.
you gave it CNN, but you can give it any source. Or you can put Google search in the beginning and create another list. It's just I have to show you how to work with lists. And
Good.
then when you learn how to work with lists, you can combine any kinds of lists and any types of hierarchies and do whatever you want. So this is a very key point, that we can filter, we can find information that is relevant to me. And again, guys, as you're building agents, it's like I was saying the last time, you have to think, how does a human does something? So when I'm researching a topic, it's exactly that. I search Google for something, I get some links, I look at them first, I see the ones that maybe are relevant, I click on them, I see how relevant they are, then I move to the next one. Here we want to do the same. It's just we outsource all this job to an agent. So first, it filtered everything just to get the information that's relevant to me. Now I wanted to read each of those links, understand what's in there, have a summary, and then come back to me with that summary. But not just that, what we can also do, we will put the full text of these articles into our vector memory. So we
Nice.
will automatically build up the knowledge, the memory that is available to all our agents using an approach like this. So how do we do that? This is where this mapping node comes in. And it's a bit tricky and a bit complicated to use at this point. So please follow us. We are working on simplifying the interface as much as possible. There will be improvements and adjustments, but it's just such an exciting functionality that I want to share with you the way it is. And then we will make it easier and you will be able to use more of it. So what is the mapping node does? You can create a sub-agent that works with one item of your list. For instance, here in the list, we have a title of the article and the URL of the article. So what we want to do, we want to create an agent that reads this article, summarizes it to me via LLM, and puts the full text of the article into vector memory so that I can come back to it in the future. And how do we do that? So we use a node that's called for each. Here is a node that's called for each. We drag whatever is in our JSON into inputs here. And then we will see the structure of our JSON here. It returns title and it returns URL. Then we can start building the sub agent that this mapping node will map over all of the items on our list. So we can have here a readability node again, because we need to read the contents. So let's take a URL, put it into the attachment. And then what we want to do, as mentioned, we want to do two things. We want to summarize it via LLM, and we want to put it into vector memory for further use. So for that, we do save to vector memory, and we just drag the content into input to embed. We need to make sure we have chosen the right memory set. Yes, it is right here. That's it. This node does not need to be connected to anything. It will just save to vector memory, and that's it. And now we also want to have a short summary. To have a short summary via LLM. So first of all, these connections we don't need anymore. Short summary, we will do like this. We put content here to user prompt. We make this GPT-4o, and we ask it to summarize the article given to you in maximum one paragraph. Assess how relevant it is and how important it is for me to read. Now, this is vague. Of course, you can give much more specific instructions. I just wanted to run and see what happens. But
okay, so one specific question for this. So one of the problems that you will run into is that there will be a lot of duplication when you search for the media. So it can be relevant, but there's another item that is very similar to that. Is there any way to circumvent this problem?
Yes, but it will require additional tweaking, so we're not going to do it now.
Okay.
Okay, and then we have to connect another node that is called for each return. And again, as I mentioned, it's a bit complicated at this point, but basically what you do, for each agent kind of starts your sub-agent that will run on every item. And then for each return is the node that ends your sub-agent. So here, just put this here. Okay. Okay, yeah, probably. So with GPT, it won't work like this. So we will just connect it.
So what did you do? What happened here?
Yeah, no, I just connected the output of the LLM node to our agent outputs, and then to for each return. So basically, for each return will give us a list. In theory, we will see if this works. It will give us a list of summaries by this LLM, and then we want to see the full list. So to see the full list, there is another node that's called text join. We connect it again to for each return, and here we just have a template that joins all of them together. So let's see if it works. So basically, what we expect from this agent, we expect from this agent that it will save every article that it has given us in this list into our vector memory, so that we can choose it and use it for later. And then we have a summarizator LLM node that will read every article, summarize it for us, and then we combine all the summaries together into one huge text. And again, bear with us, guys. This is just fresh off the press. We haven't tested all of the different scenarios, so hopefully it works. If not, we will.
This is amazing. If that will work, that will be impressive. I just imagine how much time it would take without all these blocks to kind of come up with a system that does this.
Exactly. So let's try to run it again. Let's see what happens. So we will give it some time. Once again, what is happening? Readability has read the CNN website. Then first LLM node creates this well-formatted JSON output of all the links that we need. Then this for each is running, and we can check in the logs that it is running. Yes, it's running. Okay, and actually the text join has finished as well. So let's see. Yeah, it worked. So let's see in the chat how it looks like. Okay, the formatting is a bit weird. I know why, because Markdown treats this equal signs that they put as a header. But basically, so this is the summary of the first article. Then there is a summary of the second article. Then there is a summary of the third article, etc. And again, this is just really quick and dirty. So what we did, guys, we parsed the whole CNN website, and we can make it not CNN. We can put any other website there right now. It will give us the same articles in the list. We have read only the ones that are relevant, because first LLM filtered out all of the junk, all of the links that are not interested to me. I asked it just to give me the links that are about Ukraine or about technology. So it gave me those links. We can see that here. It gave us those links in the JSON output right here. So the links about Ukraine and about technology. Then we have this mapping node, without which, as Andre mentions, we would have to write some code that takes this array that calls this subagent separately. So of course it's doable, but it's boring. It takes time. Here you can do it visually. And
so
then
you know what we just did, Anton? We turned the media space into a restaurant. You can now control what's on your plate.
Exactly.
Where you would usually be fed all kinds of junk that you don't really want to read about or hear about. Now you can tell what you want.
Yes.
That ties very nicely to the previous stream, to the menu analysis.
And this is, guys, this is one of my personal, frankly speaking, big motivations. I want to give people control. I want to give you control over AI, so that it's not the AI that thinks that something is better for you, but you tell it what you like, you tell it what you want, and it learns you, and it gives you the results that are relevant to you. And this is one of the steps to do that. So here we did that. We also put the articles into vector memory. Let's actually check that has happened. Let's go to the main. As you can see, previously we only had an article about Anton Antic. Now we have put all of these articles here. So now when we talk to an agent that is connected to this vector storage, it will talk about to us about Ukraine. So for instance, let's test a quick query. Something like, talk to me about Ukraine, and let's see what it returns. So it has returned a bunch of different articles. So we have to put the threshold a bit lower, and probably something 0.65. But then you can have an agent that talks to you about all of this or about anything. So this way, again, with a very simple agent that wasn't possible before, we have created something that gives us summaries of what is relevant to us, but not just gives summaries, it also populates our vector memory so that in the future we can come back to this information. And this means that your agents, if you run this agent every day, imagine, it will build up a vector memory with the knowledge that is relevant to you. And it shouldn't be just the news sources, obviously. We just took CNN as an easy example. But I will build an agent that I long wanted for, that will read all the AI research papers on archive.org. And there are 300 new papers every day. Impossible to follow. So I will use a very similar approach, and we'll build an agent that reads abstracts of all these papers, finds the ones that are relevant for me, for us, what we do at Integral, because at Integral we like to have very small amount of time from research into product for cool features. It will summarize it, it will put it into vector memory, it will give me summary, then I will review the ones that are more interesting, and this way it's just, I become much more productive, and any one of you can as well. And once again, here we built it live, it's a live show. It was kind of quick and dirty. I will finish building it because this is amazing and I'm beyond excited myself. We just have this mapping node today. I will build it fully. We will make it available as featured sample agents, and then you will be able to use them for your own pleasure. You will be able to plug in your own sources, filter based on information preferences that are interesting to you, and build up all kinds of research that you want. Because this is just the first step. With all of this information, we can ask another agent to build a report. For instance, what Andrei was saying in the beginning, if we don't give it a CNN, but we start with Google search, we can have an agent that we ask, prepare for us a report on the US economy. This agent will formulate Google query, will find different links, will find the ones that are relevant, will read all of them, will summarize them, will put them into vector memory, will create a long report, then another agent will create a shorter, nicer report based on it, etc., etc. You get the idea. It's
so the first thing that came to my mind when we saw the whole picture is that we're very close, like, to giving like a super powerful tool to anyone who does research.
Exactly.
Like,
It's
yeah,
your
you
own
mentioned
personal
archive.
research assistant, as I
Yeah.
mentioned.
But you could also go to Google Scholar. There's a topic that interests you.
Totally.
You can prepare like a literature review, a bibliography, a list of references. You can essentially just with a click of a mouse have something that monitors anything that is relevant to your research that is released.
Yes.
So and you only keep things on your agenda that are relevant to you. You don't have to dig through the
Yes,
stuff.
exactly. And the guys are asking on the chat if we will share. As I mentioned, yes, we will share. We will build lots of agents around this technology. We will share all of them. And also, it's like now it's only web, but imagine we also attach your email, and it's easy to attach the email right now. Now, this way you can get a real personal assistant, not the semi assistants that are available in the market right now. But this assistant will read the whole internet for you. It will read your email inbox for you, and during the morning coffee, you can also attach text to voice, obviously, to this agent. It will tell you, dear sir, here are the important items for you to think about today based on your email communications. Here are the important news that happened in the world. Here are the developments in the AI space. You hear all of that while you're drinking your coffee. Then you say, okay, I'm interested to dig deeper in this and that. The agent digs the full context and talks to you about it. That is what I'm talking about. That is real AI. And this is something that becomes available today. So this is really huge for Integral, for us. Come, join us, build with us, share ideas, but it's all going to be even more exciting from now on.
All right. Thank you very much. Another thing that, do we have a moment? Do we have a minute?
Yeah, I think we have a couple more minutes because...
Another thing that came to my mind is that a lot of information and kind of the news that I read, they come from Telegram, for example, and there are hundreds or thousands of channels, and it's very repetitive, and it's a lot of digging, but it's the only source where you can get the fast and relevant and kind of unbiased, to your taste, somewhat news. And now there's a way to kind of aggregate it all and
Telegram, Twitter, whatever fits your taste, you can put all of it together and have a really nice research assistant. Well,
that's pretty cool.
Yeah, thank you guys. Thank you for being with us today. Again, it's has been an amazing day for us. Thank you for being with us. Shoot the questions, shoot suggestions, join our Discord, join Integral. You will see the link to Discord when you join Integral. If you have any ideas for the agents, now we have pretty much the full tool set to build really advanced agents. We are ready to take on them. So come to us, share, let's brainstorm, let's build it together, and let's make the future AI agentic. And we'll see you. Well, actually, yeah, next week we won't see you because we are traveling to the US for the Amazon reInvent. If anybody is at Amazon reInvent, please come talk to us. But after the week after, we will resume and we will continue with Cooking AI Agents Live. Thank you, everybody. Anton Antic and Andrei Kovrizhny has been with you.
Thank you.